All right, so again, this is 2.6 slash 2.7. We just put them both together. So we are going to be going over rational functions and asymptotes. So a rational function is a quotient of a polynomial function. Quotients mean that we divide. So you'll have some polynomial divided by another polynomial. Rational functions look like this. They kind of look like boomerangs of a graph. They have asymptotes, which for this example, our asymptote would be the y-axis and the x-axis. Asymptotes mean that they get really close to that line, but never touch. The domain of a rational function is the set of all real numbers except the x value that makes the denominator 0. So we're dealing with fractions now. We have a polynomial over another polynomial. The only restriction in our domain is going to be when our denominator is equal to 0. So let's look at our domain review. The domain of the function is all real numbers except if there is a variable in the denominator. If there is, we set the denominator not equal to 0 because we cannot have 0 in the denominator. So if we had 1 over x plus 2, we would set the denominator not equal to 0. We would get x does not equal negative 2. So our domain would be all real numbers except negative 2. Again, we have a restriction if there is a variable under the square root. We know that we can't have a negative number under the square root because right now we just want to deal with real numbers. We're not dealing with imaginary numbers. So if we see a square root for our domain, we would need to set the expression under the square root greater than or equal to 0. And if there's a variable under the square root in the denominator, we need to set the expression under the root to greater than 0, because in this case, it wouldn't be able to be equal to 0 because we can't have 0 in the denominator. So that's if we have a square root in the denominator, because we can't have it equal to 0. All right, example 1. Find the domain of the rational function. What do we do to find the domain?
You set it not equal to 0.
We set the denominator not equal to 0. So here we would get x does not equal 4. So our domain, if we did it in interval notation, we start with negative infinity. We go to 4. We put brackets because we're not, or we put parentheses because we're not including 4. Then we need the positive side of 4, so we go 4 to infinity. So this is interval notation of all real numbers except negative 4. We could also say all real numbers except 4. All right, next example. What do we do to find the domain?
Set it equal to 0.
Set what equal to 0?
Not equal.
What are we setting not
No,
equal?
you set it to the equation is greater than or equal to 0, right?
Do we have a square root
It's greater
here?
than. On the bottom, yeah.
We have a square root?
Or no, it's just, never mind.
No, so what do we do? What do we do?
So is it just normally setting it not equal to 0?
Yep, same. We set the denominator not equal to 0.
Oh, okay.
So again, we're just looking at the denominator. We can ignore everything on top. So then we solve. We're going to add 36 to both sides. So we have x squared does not equal 36. Then we need to take the square root. So we get x does not equal plus or minus 6. So our domain in interval notation, what would we start with?
Negative infinity
To what?
to negative 6.
And then?
And then 6 to infinity.
So we have 6 to infinity. But what happens between negative 6 and 6?
Oh, there's a 0, 0.
Well, we would need to include, because it's just negative 6 and 6. That's not in our domain. So we need to include what's happening in between negative 6 and 6. So we have 3 separate intervals here for our domain. So we need to make sure we include this part.
Do we do that always if it's plus or minus?
Yep.
Thank you.
So then we could say our domain is all real numbers except negative 6 and 6. All right, next we're going to take a look at vertical asymptotes of rational functions. So vertical, thinking of vertical lines, do vertical lines go up and down or left and right?
Up and down.
Up and down. So our vertical asymptotes are going to go up and down. Lines that go up and down, do they cross the x-axis or y-axis?
X-axis.
They cross the x-axis, so our lines are going to be x equals for vertical asymptotes. So our vertical asymptotes are always going to be x equals. On a test or quiz, you will get points taken off if you don't put that x equals when you're talking about the vertical asymptotes. That is super important. If you just put the vertical asymptote as 6, I don't know what you're talking about. So super important that we put that x equals. To find the vertical asymptote, we set the denominator equal to 0. So to find the vertical asymptote, we set the denominator equal to 0. So on this next slide, it's talking about the arrow notation if we had our rational function with our little boomerangs. And we said x approaches a on the positive side, we would need to come from the positive direction. So we're coming from the right side. If we said a, so x approaches a with the little negative sign, we're coming from the left, so we would start from the left side. the equation of f of x is equal to 1 over x squared. We have a vertical asymptote on the y-axis. So if we set our denominator equal to 0 here, our vertical asymptote would be what?
Zero.
X is equal to 0. Can't forget that x is equal to. So our line would just go right down the y-axis. So our graph gets really, really close to the y-axis, but never touches it. Okay, so on this slide, the line x is equal to a number is the vertical asymptote. When we have y is equal to some number, that's our horizontal asymptote. So looking at the examples here, kind of gives us the answers. It says our vertical asymptote is -3 and 3. Where did they get those vertical asymptotes from?
From the denominator.
The denominator. They set the denominator equal to 0, so we have x squared is equal to 9. Take the square root, so x is equal to plus or minus 3. So our domain of this graph would be all real numbers, except plus or minus 3.
Wait, what?
Our domain
I thought that was only for domain.
yeah, I'm saying our domain would be all real numbers.
Oh, okay.
But our asymptote, so our vertical asymptote, is x is equal to plus or minus 3.
Okay, my bad.
No problem. All right, we're going to skip the second one for now. But looking at the third one, figure C, what do we do to find the vertical asymptote?
Set the denominator to 0.
Set the denominator equal to 0. If we solve for x here, we get x squared is equal to -9. What type of number are we getting here?
Like I, right?
Yeah, well, we're getting an imaginary number. So we're not dealing with imaginary numbers for our rational graphs. So if we get an imaginary number, we do not have a vertical asymptote. So there is no vertical asymptote here. Because if you think about it, will this denominator ever equal 0? Can we ever get x squared plus 9 to equal 0?
Nope.
X squared is always going to be a positive number, or 0. And then if you add 9 to it, it's always going to be a positive number. So we will never get this to equal to 0, so we have no vertical asymptote. All right, we're going to skip this next slide. We'll come back to it. So here we have 3 examples of graphs with horizontal asymptotes. So looking at our first one, this is our function. What is the degree, the highest degree of the variable in the numerator? Just 1. So our degree is 1. What is the degree in the denominator, our highest degree of our variable in the denominator?
2.
2. Is 1 less than, equal to, or greater than 2?
Less than.
Less than. So what type of horizontal asymptote do we get when our numerator is less than the degree of our denominator?
A horizontal.
Well, yeah, these are all horizontal asymptotes.
Y equals
Y equals what?
0.
0.
yeah.
So our horizontal asymptote is y is equal to 0. Because our degree in our numerator is less than our degree in our denominator. So anytime it's less than, your horizontal asymptote is y is equal to 0. All right, and the second one, what's the degree of our highest polynomial in the numerator? The degree of the, not the coefficient,
2.
2. What's our highest degree in the denominator?
2.
2. 2 is equal to 2, so what do we know about our horizontal asymptote?
It's gotta be y equals the highest coefficient or the largest.
So we take the coefficient of our numerator over the coefficient of our denominator. So this would be 4 over 2, which is equal to 2. So our horizontal asymptote is y is equal to 2.
Oh, so you actually divide it?
Yeah, we simplify. Right, and looking at the third one, what's our highest degree in the numerator?
3.
3. And what's our highest degree in the denominator?
2.
Is 3 greater than, equal to, or less than 2?
Greater than.
Greater than. What do we know about our horizontal asymptote when our numerator is greater than the denominator?
That there is none.
Awesome. No horizontal asymptote. A second. We're going to go to the one right after. So finding vertical and horizontal asymptotes. Our vertical asymptotes, like we said 100 times, occur when the denominator is equal to 0. Our horizontal asymptotes occur. We have 3 different types of horizontal asymptotes. If our numerator, the degree of our numerator is less than the degree of our denominator, then the graph has a horizontal asymptote of y is equal to 0. So if we have x squared over x cubed, the degree of our numerator is 2, which is less than the degree of our denominator, which is 3. So our horizontal asymptote here would be y is equal to 0. So if we get less than, it's y is equal to 0. If our numerator is equal to the denominator, the degree of our numerator is equal to the degree of our denominator, we have a vertical asymptote of the leading coefficients of those highest degree polynomials. So if we have 4x cubed over 2x, let's say just x cubed. X cubed would have 1, so we take the coefficients of our highest degree polynomial, and that is our horizontal asymptote. So our horizontal asymptote would be y is equal to 4 over 1, which is just 4. So that is if our degree of our numerator is the same as the degree of our denominator, if they're equal. If our degree of our numerator is greater than the degree of our denominator, so if we have x cubed over x squared, then we have no horizontal asymptotes. So looking at A, well, we need to find the horizontal and vertical asymptote if there are any. And we're going to skip graphing for now, so we're not going to graph it. So what do we need to do?
Oh,
What was your question?
I was gonna say, are we gonna have to graph on the homework?
On the homework? Okay, what do we do to find our vertical asymptote?
Equal to 0.
Set our denominator equal to 0. So we get x squared is equal to 36. We take the square root of both sides, so x is equal to plus or minus 6. So our vertical asymptote is plus or minus 6. So how many vertical asymptotes do we have?
2.
2. What do we need to do to find our horizontal asymptote?
Now you look at the degree, it's 1 and 2.
So we look
Or
at
1 is less than 2.
1 is less
So
than 2.
0.
So our horizontal asymptote is y is equal to 0. Perfect. Any questions on that one? All right, let's look at B. What do we do to find our vertical asymptote?
Set it equal to 0, the denominator.
Set our denominator equal to 0. So we get x squared is equal to 4. What are our horizontal asymptotes?
X equals 2.
Just 2?
And plus or minus 2.
Plus or minus 2. We take the square root. When we take the square root of 4, we get plus or minus 2. Alright, now for our horizontal asymptotes. What do we look at for our horizontal asymptotes?
The coefficients and the what's it called, the exponents of the numerator and the denominator.
So what are our exponents of our numerator and denominator?
2 and 2, so they're equal.
So now we need to look at what?
The coefficients and divide them, which equals 3.
Perfect. So we look at our coefficients. So we get 3 over 1, which is 3. So our horizontal asymptote is y is equal to 3. We cannot forget that y equals. All right, let's look at C. What do we do to find our vertical asymptote?
Set the denominator equal to 0.
So we get x squared is equal to negative 1. What happens
Since
now?
you're going to be working with imaginary numbers, you just don't do it.
We just don't do it. So what do we know about our vertical asymptote?
It doesn't have a horizontal one.
It doesn't, are we dealing with horizontal right now or vertical?
Oh, no, vertical.
So it doesn't have a vertical asymptote. So we have no vertical asymptote. So if you deal with imaginary numbers, like Andrew said, we just don't do it. So we have no vertical asymptote. What about our horizontal asymptote?
It's gonna be 2 is greater than 1.
What is our...
Or 1 is less than 2.
1 is less than 2, because we start with the numerator first. So 1 is less than 2. What do we know when we have less than?
It's equal to 0, y equals 0.
Y equals 0. Perfect.
Do we turn these in?
No. Like I said in the beginning of class, we're doing these notes over 3 days, so you don't have to turn them in. The assignment shouldn't even be on your to-do list, because I put it as not graded. We're going to do one more example, because there's some like this on the homework. So if you have f of x is equal to 1 over x plus 2, what do we need to do to find our vertical asymptote? Vertical asymptote first.
Set the denominator equal to 0.
Set the denominator equal to 0. So what do we get for our vertical asymptote?
X equals negative 2.
X is equal to negative 2. What about our horizontal asymptote?
I mean, they're both 1.
What is the degree of our exponent in the numerator?
Isn't it technically 1 since everything has an exponent, or no?
Does the numerator have an exponent?
Oh, I guess not.
No, so what would the degree of our exponent in the numerator be?
0.
0. We don't have one, so the degree is 0.
So 0 is less than 1?
0 is less than 1. What do we know when we see less than?
That's
Equals
y
0.
equals 0.
Y equals 0. Perfect. So that's it for the notes today.